Many times in programming, our code has to deal with arrays where we don't know exactly what's inside of them. And if we don't know what values are inside and where exactly they are, we're unable to reference the exact element location when we need to. For this, there are ways to search an array, and we'll talk about two common ways to do this. The first approach is to use a sequential search algorithm. The sequential search algorithm searches every element in the array until it finds the value that it's looking for, or until it arrives at the end of the array. This algorithm is okay for small arrays, but it's inefficient for arrays with more than several thousand elements. Another search algorithm is the binary search. For the binary search, the array must first be sorted. So in the case of our lottery ticket array, the elements would need to be in ascending order from least to greatest. Then you would write code that will begin the search by checking the element in the middle of the array to see if it's equal, greater than, or less than the value that you're searching for. If it's greater, then there's no need to search the entire second half of the array because we know that everything over there will be greater as well. And the element you're searching for is definitely not over there. Likewise, if the middle number is less than the value you're searching for, then there's no need to search the entire first half of the array. And if the value is equal, you're lucky and you're done. If it's not equal, you've still eliminated half of the array where you know the value is not, and then you continue with another iteration. Each iteration continues like this, eliminating half of the array for what needs to be searched until you find the value or you search the entire array. This is a much quicker approach than the sequential search, and this algorithm is one that you should definitely know as it's often brought up in tech interviews. You can code all of this by hand, but if you need to use this in real life, simply use this handy util method called arrays.binarySearch. If you purchased a lottery ticket that had duplicate numbers, you'd be pretty upset. And right now, our program doesn't handle this case. So let's update our class to ensure that there are no duplicates, and we'll do that by searching the array. And I'll show you both the sequential and binary searches. So let's look at our generate numbers method. We're generating a random number and then we're just storing it inside of this array. So there is no guarantee that this number will be different every time we run this. And so we want to get rid of these duplications. To do this, before we add this number to the array, we need to first search the array to see if that number already exists. So what we're going to do here is we're going to come right inside of this loop, and instead of assigning this directly to the array, let's put this in its own variable to start off with. So we can say int random number. And now we want to search the array. So we want to at least search one time. And if the number is already in the array, then we'll need to generate another number. So let's put this inside of a do while loop. So we can say do, and we will actually take this and put this inside of the do. So let's just declare random number. And then inside of here, we'll say random number equals this. And now we're going to want to search. So in this while, we're going to make a call to a new method that we're going to create that says search. And we're going to give it our array, and we're going to give it the number that was generated. Then after we come outside of here, so we're going to keep looping until it finds a number. So search is going to return us a true or false. true if it actually finds the number in the array, meaning it's a duplicate, and so we'll loop until it's not a duplicate. Once we get outside of the array, we know that number is good, and we could go ahead and assign it. So I'm going to go ahead and just add some comments to this, just so we are all following along. Okay, so let's go ahead and make this search method. Public static Boolean search. And this will take the int array. So we'll just say array and int number to search for. So while we're on to comments, let me show you another type of comment in Java. So if you do the slash and then 2 asterisks, this turns green. And when I pressed enter, all of this was pre-populated. This is a special kind of comment called a JavaDoc. And with this JavaDoc, we can give a description of how this method works so that if anyone wants to call us, they can see the JavaDoc from where they're calling for. And so this gives them some helpful information about how to use our method. So this is saying search, but it doesn't really say how it works exactly. So we can put a little information to say what kind of search we're doing. For example, this does a sequential search on the array to find a value. And we keep it really simple. You put as much as you want, and then you describe what these parameters are. So for the array parameter, we can say that this is an array to search through. And the number to search for, this is the value to search for. And what is it going to return? It'll return true if found and false if not. So this helps us without having to read through the code to see what it does. We can just have this nice little description. Okay, so inside of here, the sequential search, we're going to loop through the array, and then we're going to look at each value in the array, each element. And if that element's value is equal to the number that we're searching for, we're going to return true. So I'm going to show you a new type of loop that's called the enhanced loop. So let's just say this is called an enhanced loop. And what this does is it iterates through the array and each time assigns the current element to the value. So it says for, and instead of doing the int I equals 0 and all of this stuff, we can just declare something. So we'll say int value. And then we use a colon and say, what do you want to loop through? So this is saying to iterate through array, and each time assigns the current element to value. So this is the enhanced one. So the first value will be the value of the first element in the array. And so we can say if value is equal to the number that we're supposed to be searching for, go ahead and return true. So this will get outside of the loop, and outside of the method really, it's just going to go straight to the return. Now we don't put the else inside of here. Why not? Because we're looping through this. If we look at the very first value and it's not this, then it'll come to the else. And if we were to do an else return false in here, then it would exit this loop on the first one. It never even searched the rest of the array. So that's not what we want. We want to go through, loop the entire array. If it finds it, returns true. If it doesn't find it, do nothing. Go to the next one. Keep looping. Once it gets outside of the loop, that means if we've reached this point, then the entire array was searched and the value was not found. So if we get to this point, then we can say return false. Okay, so that gives us the sequential loop, and that solves the problem. Now I'm just going to show you the binary search really quickly, even though we're not going to use it. Just want to show you it in action. So I was going to call this one search and just make it an overloaded method, but I cannot because it's going to take the same parameter list, and so it won't be unique. So I'll name this binary search. Now remember the steps of the binary search. The array must be sorted first. So we'll say array must be sorted. And we can do that with this arrays class I was telling you about. It's a utility class. It has all kind of nice things in here. So one of the things that it has is this sort. And so we can just pass it the array that we got here. We pass it in. This will sort this and put it in ascending order, all of the elements in ascending order. And then we are going to say arrays.binary search. And we're going to pass it our array, and then we're going to pass it our number to search for. So if we hover over this and click the command key, it'll give us some information, the signature of this binary search. So it says that this is going to return an integer back, and I'm going to just click this. If I click this, I can see that Java doc that I told you about, and it shows me what's going on. So it says that it searches to specify an array of integers for a specified value, yada, yada, yada. What I really want to know is the return. So this is going to return to me greater than or equal to 0 if and only if the key is found. So great, we'll go ahead and assign this an integer. We'll call it index. And if the index is greater than or equal to 0, we know that it was found. We'll go ahead and return true, else return false. Okay, so that's the binary search. Sort, and then we use this arrays.binary search to do the magic for us. But we're not using that. I just did that to show you. What we're actually going to use is this search method here. Okay, so let's go ahead and run this and just make sure it still works. Great, so all of our numbers are unique. Now, even though our numbers are unique, it was hard to see that at a glance because they are in all types of order. So when we get our lottery ticket, they're typically printed in ascending order. So let's go ahead and update our program once more so that I can show you about sorting arrays. So if we go to our main method, we generate the ticket, and before we print the ticket, let's just sort this array. So we'll say arrays.sort, and then we'll give it our ticket. And now if we run this again, nice. So it's in ascending order.